Welcome to this NOMAD tutorial. My name is Marco Scheidkin, and this time we are going to use NOMAD's parsers and normalizers locally on your computer. Let's say you performed a few calculations and now you want to program with your data. For example, you want to plot charts or do analysis. Usually DFT codes output text data, and that means that you have to write some sort of a parser. Using the NOMAD parsers can be a quick way to program with your data in a uniform and code-independent way. In this tutorial we will see how to install the parsers, how to run the parsers from the command line, how to run the parsers from Python, and we will also see how to download the source code of a parser to fix bugs. Before you continue with this video, I suggest that you also watch our videos on the NOMAD Search and the NOMAD API. And if you want to follow this tutorial, you should also grab the example data that we have prepared. All NOMAD processing is written in Python, and we developed a dedicated library that you can install. And this will be the first step in our tutorial. You need to have Python 3.7 installed and to be in a shell environment like this. I recommend to start every fresh project with a virtual environment. One tool to create a virtual environment is virtualenv. Let's make sure that virtualenv is installed. Okay, I already have it. And now you can create a virtual environment like this. This will create a virtual environment based on the Python 3, and it will be created in the directory pyenv. Now you need to activate your environment. And now your environment is ready. Since the NOMAD package is a regular PyPy package, you can simply install it using pip. It's called nomad-lab. And don't forget the parsing dependencies. Now the package should be installed, and you can check like this. Okay, and we are ready to go. The easiest way to use NOMAD parsers is right from the command line. With the NOMAD package comes a command called NOMAD, which is actually a more complex command with subcommands. One of these subcommands is NOMAD parse. And NOMAD parse can be used to parse a file. Let's have a look at our examples. I copied the examples here, so I have all the files ready. And now I can use the NOMAD parse command like this. Let's say I take this here is this base group, and that's supposed to be a VASP calculation. So I run the parser like this. To make the output show, let's look at a few parameters that this command takes. There we have the ---- show archive and the ---- show metadata, which will show us some data. Let's try the ---- archive, show archive, and we pipe this into less because you will see that will be a lot of information that comes out. And this is the parsing result. This is the complete archive created by the parsers and the normalizers in its JSON representation. Let's say you're interested in the density of states data. For example, you want to create a plot about it. We know that the density of states data is stored in a section called section DOS. Now, if I search in this file for section DOS, I will find the section DOS here, and I will already see the DOS energy values. If we use the other parameter, show ---- metadata, we will also get a JSON record, but this time it only contains the metadata that are available for search. This is basically the part of data that ends up in our search engine. Okay, in principle, you could use this already. You could save the JSON and do something with it. But usually you want to use Python to do your further analysis or chart plotting. So the next step that we are looking at is like using the parsers right out of a Python environment. Let's write a small script for parsing. I call it parsing example. The first thing that we need to do is to import a few things. So from the NOMAD command line interface, from the parse command, I import the parse function and the normalize all function. The parse function will create an archive for me, which I can store in a variable called archive. And then I need to give a file to the parse function. So you see it's very similar to the command line interface. I will simply choose the file that we just used on the gallium arsenide, and it was a was run XML file. Then we can normalize the archive, or the information in the archive rather. And now let's just print the archive and see what happens. So now we need to run it, Python parsing example py. And this will run the parsing for us. So the file gets parsed and normalized, and we get the output here. As we see, in this case, the output is an archive object, and the wrapper of the archive object will show us the first level of subsections that are contained in this archive. So we have an archive here with a section run, a section workflow, and a section metadata. If you know NOMAD a little bit, you know that the section run contains all the information that was directly passed out of the file. The section workflow contains an aggregate about the workflow that might have been performed as part of the calculation. And the section metadata contains the search metadata that will end up in NOMAD search index. One simple thing that you could do with the archive is simply serialize it to JSON, similar to what the command line interface did. For this, we will import the JSON package. And then we will, instead of printing the archive, we will serialize it and print its JSON output. JSON dump. And then we need to transform the archive into a Python dictionary object that is serializable. There's a function called m2dict that we can use on each archive object. And this will basically give us a JSON serializable dictionary that we can then serialize with the JSON dumps command. Let's try this. And voila, we get all the JSON data that we had before. In the description for this tutorial, you will find a few Python examples of things that you can actually do with an archive object like this. Now in this demonstration, everything runs rather smoothly. And while the support for popular codes like WASP is quite mature, the support for smaller codes might be still under development. If you believe in the utility of parsing and are willing to contribute, we would very much appreciate. Let's see what you can do to actually further develop a parser. We organize all our source code in a GitLab that's hosted by Max Planck in Garching. Each parser has its own Git project, and all parsers are organized in submodules to the main NOMAD project. Cloning the whole NOMAD project and all submodules requires a rather complex setup, but there's a simpler way to simply install a single parser on top of the NOMAD lab package. So this is the source code of the NOMAD project, and if we go to dependencies here and to parsers, we will find all the submodules to all the parsers. Let's say we want to improve the WASP parser. Let me scroll down to the WASP parser. So now we found the Git project for the WASP parser. What we can do now is simply clone this parser. So I go back to my shell and simply git clone this URL. This will download all the source code of the WASP parser. And now I can start changing the source code for the WASP parser. Let's say I jump into the main parser WASP run file here, and I want to change a simple thing. Let's say I want to change how the basis set is represented in the results. Basis, can we change the basis set? So this is the part where the basis set property is set in the section run. And now I make it just a simple change for demonstration purposes. I will simply add, I don't know, a hello world here. Now the idea is, if I rerun the parsing from before, that I will now get the hello world in the basis set. Let's redo this command, and this time I'm grabbing for the basis set, just to see if our change worked. So now I get all the information that contains somehow basis set, and I see the program basis set type is still set to plain waves, so it did not work yet. So what's the problem? We downloaded the source code, we changed the source code, but obviously the system is still executing the old installation. There are a few ways to fix this. One way to fix this is to tell Python to rather take our downloaded source code over the installed source code from the NOMAD Lab package. A simple way to do this is use the Python parse. I simply export a variable called Python parse and give it the source code directory that we just downloaded. Now let's try to execute this again. And this time our hello world appears. Basically now you're set up to change the parser, use the parsing and reflect all the changes. If you are a project member and if you have a GitLab account in Garching, you can make contributions directly to our GitLab. If you don't, just write us an email and we find a way to include your contribution. This concludes our tutorial. We looked at how to install the parsers, we looked at how to execute the parsers from the command line, how to execute them from Python script, and also how to download parser code to change it. Please also watch our videos on uploading data to NOMAD, on NOMAD Search and the NOMAD API. Also look out for future webinars on the Materials Encyclopedia and data analysis. Thank you very much.